Hi RAP students, this is Dr. Smith here to talk to you today about the skeletal and the muscular systems. So we're going to start off today talking about the skeletal system. So this is how I like to explain it. I have Mr. Moose here. Mr. Moose is not alive, of course, but we can use him as a good example for the skeletal system. You notice I have to hold Mr. Moose up. If I let him go, he falls down. If I sit him down, he falls down. If he had a nice framework inside, a very rigid framework, we could at least find a way to stand him up or to sit him down without our help. That's what our skeletal system does for us. It also protects our bodies. So if Mr. Moose had something thrown at him, and if he was alive, he's so soft that it's going to hurt him. That's going to cause some serious damage. Our skeletal system protects us that way. Also, if I want him to move, I'm going to have to do it. He does nothing. So if I want his arm to move, I have to move it. If I want his legs to move, I have to move it. The skeletal system helps with that also. Now, the one thing a lot of people don't think about, or a lot of people don't even know, is that the skeletal system also has blood cells within the bones. But for right now, we're going to focus on just the protection, movement, and shape of your body. Okay? All right. So the skeletal system consists of bones. What bones are, they're a hard material in your body, and how they're formed is you have collagen, just like if you used to feel your nose. It's all flexible and you can move it all around. You can do the same thing with your ear. That's because they're made of collagen or a type of cartilage. Your bone has that same material, but what makes it tougher and stronger is that it has calcium that also makes up the bone. So that's how it protects us. So we like to put the bones, all 206 in our body. That's how many bones are in the body. Unless you have extra fingers and toes and things like that. But we like to put them in two different categories. The first one is called the axial skeleton. The axial skeleton keeps us upright, just like we want Mr. Moose to be upright by himself. So I'm going to attempt to draw, and for you kids, it's okay if you laugh. It won't be the first time. So we have what's called the skull. Here's my attempt at drawing the skull. Holes for your eyes and your nose. And then your bottom jaw. After that, we have the the spinal column, square bones. Now, I'm only drawing a few of them, but there's a lot of bones in the spine. And then next, we have the pelvis. That's my attempt at drawing the pelvis. I know it when I see it, though. These bones keep you aligned. So this is the skull or cranium. It protects your brain. This is your spinal column. It protects your spinal cord that runs through all of those bones. And this is your pelvis. It protects your private parts as well as your bladder. Now, what's missing from these axial bones, we're missing the ribs. The ribs come across here like this. Yes, I'm not a great drawer. Let's act like I am. You get the idea, though. Okay, and the ribs protect the soft organs inside, the very, very, very important organs like your heart, your lungs, your kidneys. They come down kind of far so they can get your kidneys in there, your liver, your spleen, your gallbladder, all those organs that we need. That's your axial skeleton. The second set of bones are the appendicular bones. Now, if you don't know this word and it seems kind of out of reach for you, you can learn it, but it's not serious if you don't. You just need to know what these bones do, and they help with movement. And these are usually in your arms and your legs, fingers, toes. These are usually the long bones, and they look like this. This is what most people think about when they think of bones. There's something like that. Now, the reason they're called long bones is because they grow longer. Kids have a place on their bones that sits somewhere along in here and in here. And you have that collagen at those lines. And it continues to grow cells for your bones. So if you have a break in a bone, so the most complicated one can be right at that line, depending on how it is. But a lot of times when kids have bones that break, so let's say that your bone, you had a clean break this way. The fact that your bones are still growing and they're more cartilage than our adult bones, you tend to heal a lot quicker. So it's the older people that have to worry because we aren't growing bones anymore. I'm as tall as I'm going to be. Smaller kids, you're going to continue to grow. And so your body's used to doing that. Okay, we just have to make more bone. So for us, it takes longer. For you, not so much. So this can be healed in just a little time. If you go to an orthopedist, they will look at that. They may put you in some type of splint, or just depends on where it is, what bone. But they're usually pretty confident that it's going to heal and heal quickly. So these bones are called long bones because they grow longer. And usually they have with them, like usually all bones do, they have some type of joint. So not only do we have bones, we have joints. And so the joint can be in between bones, like this. Again, I'm not the best artist. And so the joint is in between here, and the joint helps with movement and it cushions. So you can have some cartilage in here. Cartilage is like that collagen where you have in your nose and on your ear. It's more flexible. It serves as a cushion when you start to move. And you can even have some fluid inside. And more cartilage could be on the outside. And it just helps with better movement so you can move smoothly. So you'll have that with your arms and your legs, your fingers, your toes. And just a fact, the largest bone in your body is the femur. It is your thigh bone. And that's a long bone. But we also have really small bones. There are 3 really, really, really small bones that are in your ear. Just so you know, you do have bones in your ear also. So just keep that in mind. So now that we've talked about the skeletal system, let's add in the muscular system. So now let's talk about the muscular system. Of course, muscles is what we think about. Muscular system. So in the muscular system, we have muscles, of course. And there are all types of muscles. The basic skeletal muscle, since we just talked about the skeleton, usually looks like this. It has two ends, and what we would call the belly of the muscle is right here. It's thicker in the middle. And a lot of people, when you ask them to show their muscles, they'll say, I'll show mine a little bit. It's not as great as it used to be. But the muscle belly is right here in the middle. That's how muscles usually work. Now with the skeletal muscle, because that's the first type of muscle, the skeletal muscle, it helps with movement. It helps to flex joints. Flex meaning flexible. So if I wanted to use this bicep muscle to flex my arm, I go like this. The muscle shortens, and you get to see the bulk of it. Now the thing about muscles, you have to work them for them to get bigger. So everybody's muscles are different. This is where we get our strength. So Mr. Moose, he can have a skeleton, but he still won't move. If we put a skeleton inside, he can be upright, but he can sit straight, but he still won't move because he needs muscle. Muscle gives us the force to be able to move. If we want his arm to move, we have to do it. That's the job of muscles. That's why the skeleton and the muscles work well together. So when we flex, we're going to bring two different bones, in this case, together. The muscle will shorten, and it'll be bigger where you can see the muscle. That's called flexing. Now when it extends, you actually bring those two bones apart. That's extending. That's what skeletal muscles do. And we can actually control that. Okay? That's something you can say, I want my muscle to move, and you can do it. Now the other two muscles that we're going to talk about, you cannot do that with them. So the next one is the smooth muscle. Smooth muscle, number 2, smooth muscle is what is in your organs. So organs have functions, and they're going to need to move some. So they need some kind of muscle. They got some really smooth muscle that they use to move, okay? So when you think about your organs, think muscles because they have to have some, okay? And the next one, which is a very special type of muscle, is cardiac muscle. And that helps the heart. The heart is a muscle, one big muscle, and it actually works to pump blood to the entire body. So that means that it has to have some force to do that, to get from here to all the way down there, all the way up here. You have to have some force behind that. So that's what cardiac muscle does. These two types of muscles, you don't control. You can't tell your heart when to beat. You can't tell your organs when to do what they need to do. But what happens is your brain controls those. There are certain triggers in your body that actually tell your organs and your heart to do what they need to do, okay? Now, with the heart, a lot of people don't know, I'm just going to throw this in, that heart muscle can actually work on its own too. It has a little bit of special power, as I'll call it right now, is that it can sometimes have its own rhythm, even if there's a little bit of a problem. But that's a little bit more specific, specified. So don't worry about that right now. Just understand that there are different types of muscles and that you can't control them all. So now that we know that the nerves that go out to these muscles actually go to the brain. The brain is going to tell those when to work. And the skeletal muscle, we can control. So what I've done is I've created a model so you can see kind of how these things work. So let me have a seat here. So since we're so used to the bicep, I created a homemade bicep right here. And these rubber bands are the muscles because muscles are flexible. So you see how we can move that like that? So if you want to do this at home, that's great. I used what I had. If you're doing a home project, that's what you do. You don't have to spend money on it. Now, if you were wanting to compete in a fair or something like that, make this your prototype, okay? And then go from there and get it as lifelike as you can. So this is the top part of my top part of my arm. And these two, because the arm has two bones in it, this is the bottom part of my arm. Just think of a hand being right here. And so there is a joint in the middle. I just took a little teeny football. It's kind of squishy. You use what you use. And you can count the duct tape or the black part as some of the cartilage, and some cartilage can also be the football there. And if you notice that the muscles cross a joint, that's how you get it to move. So there's one attachment here and one here, or two right here. But if this was attached, this attachment was down here, we wouldn't be able to move the arm. So that's how joints work. You have to have them cross a joint if you want that joint to move those bones. And so when you flex, remember the two bones come closer together. And so you would flex this way. Now the thing about muscles is they only flex. So if the muscle's here, how are we going to get it back to the original position? Now what's missing from this model is the muscle on the other side. So if you have a muscle on the other side and it flexes, then that would help straighten that joint out. So you need muscles on the front and the back so that you can flex and extend like that. Now, we talked about the long bones, but let's use a different type of bone. I actually made a spine just with things around the house. I had some skewers, little sticks that you can use for kebabs or whatever you put, meat, fruit, vegetables, whatever it is you want on it. And I took a carton like this and I cut it up. And I had some foam pieces around the house, and so I just got foam pieces. And I put holes through the little egg carton pieces, and in between, they're the bones, and in between, I put the cartilage where the joint would be. So as you can see, not all joints look the same. This is a long bone joint. And this is a little short joint. So even your spine has joints. That's the only way that we move. Now, what's wrong or what's not so great about this model is we turn our spine, we can actually go from side to side. You can't do that with this. However, instead of the skewer, if you were to use a pipe cleaner or two, you could probably get the different parts to move from side to side. Now what we can do is we can turn these. So they are somewhat flexible. So this is the prototype. Your next version would probably be with the pipe cleaner so that you can get even more movement. It'd be more like the regular spine. So these are some really good things for you to do, and you can continue to perfect. And it would be great for projects. I would encourage you or challenge you to learn more about different joints and try to make them as close to lifelike or as functional, meaning being able to do exactly what the real life joint does. And you will gain a better understanding of how these joints work. That is all that I have for the skeletal and the muscular system. I hope this was very helpful, and I challenge you all to try to make better models and include more detail. And remember that it is important for you to exercise your mind as well as your body. I've enjoyed this time. Until next time.